Hello student, if you are a part of our class Engineering Mechanics Section C in the year of 2022, in the very first assignment, we have given you a problem. So we are going to discuss the solution of the problem. Many of you actually done it correctly. Those who have not understood, you can watch this video and you can get your concept clarified. If you have made any mistake, that also you can rectify. So let us understand the problem step by step. So the problem says, the body shown in the figure is separated by a uniform stud weighing 100 newtons, which is attached to the body which is frictionless. So there are body that you see here, body A and body B. These are separated by a uniform strut. This is the uniform strut weighing 100 newtons. So this strut actually, it is having a weight of 100 newton. It is attached with a frictionless pin in this two body, say body A and B. This is the pin point. Now the coefficient of friction under each body is given, means in this surface there is going to be friction, in this surface there is going to be friction. So the value of the friction is 0.3. So the mu value has been given, which is 0.3. The question is, determine the force P that will just start the system rightward. You see on the body A, there is a force P acting in this direction. You have to determine the magnitude of the P for which this block has a rightward movement in the impending motion, right? You can see it here, just start the system, means rightwards impending motion. And what is the requirement of the force P that you have to find out? In this problem, the weight of block A and the weight of block B both are given. This is the problem that you have to solve. So let us try to solve the problem step by step. I have put you the same figure here. Now let us just try to inspect the problem first. You have to determine the force P for which this is in the impending motion this way. Now if you just draw the free body diagram of this part, can you solve the problem? Let us see. So let's see, in the block A, we have the force system. Let us see. So first you have the external force P acting on the block. There is going to be normal reaction. The body is going to have impending motion in this direction. So the frictional force is in this direction. Then we have this strut, right? For this one, we are going to also have some force. So how many unknown force we have? By the way, the frictional force we can find out. So this is known to you. The unknown force is this, and this is also your unknown force. So there are three unknown force in this free body diagram of block A. In the equilibrium equation, you have only two, Fx equal to 0 and Fy equal to 0. So you have three unknowns and you have two equations. So you will not be able to solve the problem and cannot find out the value of P. So you have to take help of other part of the figure that you see. So instead of block A, if we just try to draw the free body diagram of block B, what kind of force we may get? Let us have a preliminary idea of that. So this is block B. So this is the support. The support is inclined. So if we remove the support, we have to replace it with appropriate normal reaction. So this is my normal reaction. And the normal reaction, this is the first one. And then we are going to have the frictional force. Now, if the impending motion is in this direction, for this one the impending motion also be in this direction. So the frictional force would be in this direction. And then because of this strut, there are going to be a force also here, right? So there are going to be two forces. This frictional force we will be able to find out, right? Because your mu value has been given, which is 0.3. So the frictional force we will be able to find out. So you can understand, if we start from B, we can get only two unknown, and we can solve it by Fx is equal to 0, Fy equal to 0 at the free body diagram of block B, right? We can find out. So by inspecting the system, you can understand where to start from, right? Now let us solve the problem. Let's see what all forces are acting on the strut AB. If we just draw the free body diagram like this, so this is point A and this is point B. So the weight of it we already knew, this was 100 Newton. So the 100 Newton weight would be acting through the center, right? So this is 100 Newton, and we see that this strut is making an angle 30 degree. So this angle is 30 degree. So there is going to be a reaction force here. There is going to be a reaction force here. There are also going to be reaction force here. Since this is a pin joint, in the question you have seen that this is a pin joint, there is going to be horizontal and vertical reaction, right? So say this is this is the vertical reaction. At this point it is T1, and at this point this is T2, and in this point this is also, you have a force. Let's say this is also a tension, right? Now in this figure what you have seen that in a T and T, these two forces are equal. Here I have taken. Now many of you ask this question, why this two force has to be equal? Let's say you consider it to be different value, T1 and T2. If we take moment, or if we try to solve free body diagram of AB, what we can do is we can take sigma of Fy is equal to 0. If we do this, we can write T1 plus T2 is equal to W, right? This is T1, this is T2, here we can see this is W. Now if we take moment about MA, what we can do is we can see that it is this force actually is passing through the point A. So this force is not going to give any moment. This force is also not going to give any moment. This force is also not going to give any moment because this is also passing through the same point. And T2 force will contribute to the moment. This 100 Newton force will also contribute to the moment. So if you write the equation, we get 100 is the force, and let's say it is half L by 2. This is also half, right? So if that is the case, then L by 2 into cos 30 equal to, we can write T2 into L cos 30. So L cos 30, L cos 30 we can remove, and what we can see is if we solve it, we find out T2 is equal to 50, right? So if T2 is equal to 50, if you replace it in this equation, here W is basically your 100. If you replace 50 in this equation, you can get T1 is equal to T2 is equal to 50 Newton. So you can see in this chart, this is having a self weight of 100 Newton, and it is going to get the same amount of support from this point A and B, right? So this part you have understood. If you follow the question, the coefficient of friction of each body is given 0.3. If you want to write in this way, you can find the value of phi also. That's what I have done here. So this phi is the value of the angle of limiting friction, which is the angle made by the resultant force with the normal reaction. Now we will draw the free body diagram of the B. So if you have to draw the free body diagram of B, how we can do it? Let us see the force once again. So this is the body B, and there is going to be a normal reaction which is perpendicular to the support. This is N, and then since this is an impending motion in this way, this is going to have an impending motion this way, the frictional force is going to be this way, right? And there is going to be a resultant force. The resultant force is, say it is R, and the angle that it makes, it's 16.7 degree, right? And this is the normal force. This N, since this block is inclined at a plane which is at 45 degree angle, the value of N, this is going to be, this angle is going to be 45 degree, same as this one, right? So in the class we have explained like how easily you can calculate, you can estimate the normal reaction if it is in an inclined plane, the same principle that we are applying. So you can understand there is a frictional force, there is a resultant force here, and there is going to be weight of it. So if you follow the weight of it, for the B it is 200, right? Now remember that the block B is having 200 weight, and from this start there is 50 Newton weights coming, right? 200 plus 50. So here you see the free body diagram of the B. So you see 200 plus 50 here, and the same reaction forces that I have shown you, making a 45-degree angle with the vertical, and then you have the angle 16.7, and the frictional force direction also you see. Because of the start, you have seen that there is a force here, T force. If we just go back here, so here if it is making a reaction, if it is getting a reaction 50 Newton from this block B, obviously on this block it is going to apply 50 Newton force, and in the start if it is going to apply a T tension, then obviously in this block it is going to experience T force, and this 50 Newton force you have coming from the this uniform start, and this block B is going to have 200 Newton. So that is how you are getting a total weight of 250 Newton acting vertically downwards. Now the angle of the T force, if you see, it is making an angle 30 degree here. So if you are considering the block, you can see the force is also acting at an angle of 30 degree. So this is a free body diagram of the block B. If you are able to draw all the forces in the correct direction, you can orient the forces in this way or in this way, depending on which method you use. You can use the Lamis theorem using this method, or if you want to use the law of triangle, you can do in this way. Either way you do it, you will be able to find out the force T value is 258 Newton approximately. So here what you know is the value of the T here, this T value 258.6, probably that's what you are getting, right? Now we will come back to the block A. If we come back to the block A, we will be able to see that the self weight of the block was 400 Newtons, and because of the weight that is coming from the strut, we can see 50 Newton will be added. So the total force which is coming vertically downwards is 400 plus 50 is equal to 450 Newton, and then you have to find out the value of P, right? So the P force remains here. This block is also going to get a normal reaction, which is N1. Since the impending motion is in this direction, the friction actually comes in this direction. You know already the mu value is given 0.3. So you can find out the frictional forces mu times N. Since it is in the impending motion, you can write this equation. We have explained this concept in our class. Then you have the force T 258.72 that we have calculated earlier, that is coming from the strut. So these are all forces on your free body diagram A. So here you have only two unknown, force P and force N, and you have two equations to apply, sigma of Fx equal to 0, sigma of Fy equal to 0. If you do it correctly, you should be able to get the answer. But let us solve this problem step by step. So if we take sigma Fy equal to 0, let's write the equation. So so this is our sign convention we have taken. Along x-axis we have taken positive, along y-axis in this direction we have taken positive. So when you are writing sigma Fy is equal to 0, N is positive, it is in upward direction. Then we have 450 Newton acting downwards, so the sign is negative. Then we have T force, this is acting at an angle of 30 degrees. So if we take the vertical component of that, 250 sine 30, the vertical component of that, the vertical component would be acting vertically downwards, so the sign is negative. If you solve it, you get N value is this, 579.36 Newton. Now if you take sigma Fx equal to 0, you can write, if you start from here, P value is positive, x-axis it's acting, so P positive, minus F, you can see the friction force is acting on the negative side of the x-axis, so you take minus F1, and then for the T value you are going to get a negative force because it is also acting in this direction, right? So 258 cos 30, if you equal to 0, you will be able to get P value 379.86 Newton. So student, I hope you have understood the entire problem, and whenever you are finding any problem, how to think step by step and which free body diagram to start with, I think you have got a very basic idea of that. Hope that helps students. I'll meet you in the class. Thank you for watching.